All right, welcome to New 22. Factoring A equals 1 guided video tutorial. So we are moving through factoring, and as we move through, hopefully it will become more obvious, like which kind of factoring you have to do, where these kind of labeling names are coming from. But I'm going to do a little bit of an explanation for that before we get started here. So let's get started. Okay, so factoring, like I've said a couple times, is this conglomerate that encompasses a lot of different things. So there is factoring by GCF, which we've already looked at. There's these special cases. There's A equals 1. And then there's A is greater than 1. So those are the four main topics, or the four main, subgroups within factoring that we'll look at. Now, here's the thing. Special cases can fall within A equals 1 or A is greater than 1. You don't have to use special cases. It's almost a trick that's helpful. But you can use, you could always use the A equals 1 or A is greater than 1. GCF, you sometimes then have to use A equals 1 or A is greater than 1 topics. For A equals 1, A is greater than 1. The first thing, what am I talking about? The first thing is that when you're talking about it, it's based off of this. Okay? So what you're really looking at is this number. And that's attached to the x squared. So you're really looking at whatever's attached to the x squared number. And that is where we're kind of headed today. For A equals 1, we're going to be doing something that looks like this right off the bat. For A is greater than 1, you have to go straight to grouping. Okay? And then you end up with something that looks like that. For GCF, may not always look like that. Okay. Usually looks like that. And special cases, remember this is that it usually looks like same numbers, right? Okay, so now that we kind of have that taken care of, let's move on. Equals 1. It's been, I hope, a little bit more clear, what are we talking about when we're talking about GCF or when we're talking about special cases. Obviously GCF is talking about the greatest common factor. Special cases is talking about when we have perfect squares. When we're talking about a equals 1, we are talking about... So this is going to bring back memories to the diamond puzzle, okay? The diamond puzzle, at its core, it was multiply, add, factor, factor, right? With factoring, this is the multiply and this is the add of that, okay? So what we're going to do is we are going to take the multiply and we are going to figure out all the multiples. So this is where that multiplication chart really comes in handy. And although I'm going to do the multiplication chart video after I do all these videos because I'm making my list of all the things it's going to come in handy, I'm actually going to post it to be watched before all of these other videos. Okay? And we're going to list all our factors. So we're going to do 1 times 54. 2 times 27, 3 times 1, 18, 4 doesn't work, 5 doesn't work, 6 times 9, 7 doesn't work, 8 doesn't work, 9 times 6. And again, once we get to the first repeated but flipped factor, pair, I know I'm done, I can cross that out. And that's kind of my check. Now, on the right side, I'm adding my numbers. On the left side, I am subtracting my numbers. I get 55, 29, 21, 15. I get 53, 25, 15, and 3. I know I'm looking for this 21. And when I do that, there it is. And I'm looking for a positive 21 because my signs, everything tells a story here, okay? I'm multiplying to get a positive 54, and I'm adding to get a positive 21. So I know to get a positive 21 here, I want my 3 to be positive, and I want my 18 to be positive, because that's the only way to do it. So over here, I'm going to set up my parentheses, because now you're pretty familiar with this. I need these two factors, or these two terms, sorry, not factors, terms, in each of these parentheses. And in order to get my first term in my trinomial, x squared, I need x and I need x, because x times x gets me x squared. In order to get me 54 by multiplication, I need 3 and I need 18. And in order for all these signs to work out, in order to multiply to get to positive 54, in order to add to get me positive 21, I need a positive 3 and a positive 18. Now, when I check my work with that double distributive property, I get x squared, I get plus 18x, I get plus 3x, and I get plus 54. Now, if you want to check the shorter way, remember, you check the double rainbow underneath. You check these two, and you check these two. And that gives me plus 3x, plus 18x. That gets me plus 21x. which is what I wanted. And I'm good to go. Because again, this is my answer. That's what I wanted. This is just my check. Okay, that's just my double check. All right, let's look at number 2. I want to multiply to this. I want to add to this. So I'm coming over here and I'm saying factors of 45. 1 times 45. 2 times, nope, doesn't work. 3 times 15. 4 doesn't work. 5 times 9. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 times 5. Okay. Looking for adding over here. Subtracting over here. 46, 18, 14. And again, I'm listing them all because I don't want to shortchange you for the process. If you see the number that you want right here, you can stop at any time. However, there are a couple trick numbers where you will get the number that you want twice. But more than likely, you can stop when you see the number you want, which right here is 14. I want a positive 14, so I need a positive 9 and a positive 5. So if I'm plugging into my 2 binomials, I want an x and an x to get an x squared. I want a positive 5 and a positive 9. And I'm all done. If I want to do my double check, I can very quickly verbally double check my first term here and my last term here. I say x times x gets me x squared. I say 5 times 9 gets me 45. Then I say here, 5 times x, here, x times 9, 5x, 9x, they add up to get me positive 14x, and that's what I want. All right, here's where the fun comes in, where we have some negatives to worry about. Okay, I want to multiply. Whoops, somehow I have a negative. All right, I want to multiply, I want to add. So I'm multiplying to get positive 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 6 times 4, and I know I'm done. All right, I'm adding over here. 25, 14, 11, 10. Well, there's the one I want, 14. But look, here it's a negative 14. How do I get a negative 14? That must mean I have a negative 2 and a negative 12. Well, hold our horses. Let's just make sure when I subtract I don't get any 14s. This I get 23. Here I get 10. Here I get 5. Here I get 2. Okay, so it's not a subtraction problem. So I must want 2 and 12, and they both need to be negative to get negative 14, right? But how does that work in this problem? Can I multiply to get positive 24, but add to get negative 14? Negative 2 times negative 12 gives me positive 24. But negative 2 and negative 12 add to give me negative 14. You have to remember, a negative times a negative still gives me a positive, right? But 2 negatives add to give me a negative. If you owe somebody money and you owe somebody more money, you still owe them money. But multiplying a negative by a negative, that's like one of the only times in life where 2 wrongs make a right. Okay, so this one we're still okay. We're going to make our 2 binomials. We have an x and we have an x. We have a -2 and a -12. We very quickly verbally check. X times x gets us x squared. -2 times -12 gets us +24. And then here we check our inners. And I say inners because there are, or inners and our outers, right? Double rainbow. -2x, -12x, and together that gets us -14x. And that checks for our inner number, kind of our landlocked number. All right, let's try number 14. This looks very similar in signs to number 3, so we'll get another chance at it. So +36 are factors. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6, and we know we're done because anytime we have, that's actually a perfect square, but anytime we have the same number twice, we're done. Okay. We're going to add on this side. So we have 37, 20, 15, 13, 12. All right, we're trying to get to 15. There it is. But because I want -15, both of these 3 and 12 are going to be negative. When I multiply, -3 times -12 is still going to give me that +36, so I'm still good. Okay, so I have x and x, that gives me x squared. -3 and -12, that still gives me +36, so my outers are okay, x squared and +36, and then I'm going to check my inners. -3x is -3x. X times -12 is -12x, and when I add them, I get -15x. So I'm good up there. So that's my answer. That's my answer here. All right, let's look at number 5 and 6. So now my signs have changed again. Notice how I gave you 2 of each type to kind of get used to each of them. That wasn't on accident. Definitely a method to my madness there. The first 2 were both positive. The second 2 was a negative and then a positive, where you're still multiplying to a positive. Here now you're multiplying to a negative. Okay? So, multiplying to a -40. We're not going to worry about the negative when we're looking for factors, because the factor piece of it doesn't change. So we're multiplying to 40. 1 times 40, 2 times 20, 3 doesn't work, 4 times 10, 5 times 8, 6 doesn't work, 7 doesn't work, 8 times 5. We can cross that one out because that is my repeat. When I add them, 41, 22, 14, 13. And if I look, none of those matches with this -3, right? Because here's what I'm multiplying to, here's what I'm adding to. And remember, when I say adding, I really mean adding and subtracting. They're synonymous. Adding and subtracting is really, it's the same thing. It's combining numbers, right? But because I didn't find one over here, now I have to try the subtraction piece of it. So 40 minus 1 is 39. 20 minus 2 is 18. 10 minus 4 is 6. 8 minus 5 is 3. So there it is. I want to use 8 and 5. Now, here's the trick. Here is the trick. If I could put like fireworks right now with the video to go off, like, you know, when you send a text message with like fireworks or confetti or like, you know, some kind of effect, I would. Here is the trick. You know, when you look for a trick, like it's the same thing every time. This is it. I'm giving you the trick. This sign will always follow the bigger factor. So if this is negative, the bigger factor will be negative. If this is positive, the bigger factor will always be positive. Because think about it. If this is negative, your bigger factor needs to pull it into the negative numbers. If this is positive, your bigger factor needs to pull it into the positives, right? Like if you owe somebody money, okay, it needs to reflect that. Your total needs to be negative. So here, okay, it's a negative amount of money. You owe somebody something. So your 8 needs to be negative. Your 5 needs to be positive. If that was positive, your 8 would need to be positive. But it's not. Now this makes sense because when you multiply to get a negative number. When you multiply and get a negative number, there's only one way to do that. One of your numbers needs to be negative. It doesn't matter which. One of your numbers needs to be negative. To get a positive number, there's 2 ways to do it. Both of them need to be positive or both of them need to be negative. To get a negative number, one of them needs to be positive and one of them needs to be negative. Okay, so now I'm just going to come down here a little bit. When we have our 2 binomials, okay, I still have my x and my x to get my x squared. All right, to have my negative 40, I have this positive 5 and this negative 8. Positive 5 times negative 8 is negative 40. If you've made a mistake on your signs, unless it's truly like a glaring mistake, like you have 2 negatives or 2 positives mistake, you won't see it here. If you've messed up which number your negative is on, you won't see it here. So, you have 1 negative and 1 positive, you're good. It's negative 40. But where you'll see your mistake is right here, checking your inners. You have positive 5x here. You have negative 8x here, and that gives you negative 3x, so you're good. What I mean, just go with me for a second. If I were to... Oh, wow, that was way bigger than I expected. Sorry. All right. Say I messed up my signs, right? I'll do it in red so that you know. Okay. This is a mess up. This is an error. Okay. So say I mess up my signs and I go to check my work and I get negative 5x, I get positive 8x, and I put them together and I get positive 3x. Your number will be right. See how my 3's match, but my signs are off? If your numbers match and your signs are off, you know that you just have to flip your signs. So numbers matching, signs being off, you just have to flip your signs, and you know that this one would have to be a positive and this one would have to be a negative. But we had it right, so we have the negative 8 and the positive 5, and your answer is good to go. All right, let's try the next one. All right, we have negative 12 is our multiplication. So we are finding the factors. 1 times 12, 2 times 6, 3 times 4, and then 4 times 3. We're crossing that one out because we already have them all. And we are going to do our addition. So we get 13, 8, 7. We don't find the 4 that we need, so we go back and do our subtraction. So there's 11, 4, 1. So now we see it. There it is. Okay. So this is negative, which means that our bigger factor should be negative. So I have an x, I have an x, I have a 2, I have a 6. My 6 is negative, and there I have it. If I'm doing a verbal check, x times x gets me x squared. Positive 2, negative 6 gets me negative 12. I'm good there. I check my inners. Positive 2x, negative 6x. That gets me negative 4x. And I'm done. All right, very similar, but just a little bit of a sign switch. So we're going to keep, everything's going to be the same. We're just switching up our signs a little bit to give you a little bit more practice. See what you can do with it. All right, negative 18. Factors, 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, 6 and 3, and I'm crossing that one out. Adding up the side, 19, 11, 9, don't see what we need, so we subtract 17, 7, 3. 7 is what we need, so there it is. And we have a positive 7. So our sign will always follow our bigger factor. So our positive needs to be attached to our bigger factor. Our bigger factor is 9, which makes our 9 positive and our 2 negative. So when I plug into our binomial, I have an x, I have an x, I have a negative 2, I have a positive 9. If I'm checking my work, x times x gets me x squared. Negative 2 times 9 gets me negative 18. I check my inners, I get negative 2x, positive 9x, and that gets me positive 7x, and I'm good to go. And the last one, negative 21 is my multiplication, so I have 1 times 21, 2 doesn't work, 3 times 7, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 times 3, cross that one out. Addition, I have 22 or 10. Subtraction, I have 20 or 4. 4 was what I was looking for. And I want positive 4. So the 7 needs to be positive, the 3 needs to be negative. Filling in for my binomial, I have x, I have x, I have plus 7 minus 3. I haven't noted it thus far, but it does not matter which direction you put in your numbers. So I think I've done it in order for all of them except this one. But, you know, here's to confuse you on the last one. It doesn't matter whether you put the 3 in first, the 7 in first, as long as your signs go with the one that they should. It doesn't matter if yours looks different than mine too, like if like your whole parentheses are switched. Okay, so just checking. X times x gets me x squared. 7 times negative 3 gets me negative 21. Checking my inners and my outers. I have positive 7x, negative 3x. I get positive 4x, and I'm done. Go back and check yourself on the independent practice. I put up that extra independent practice labeled, I think, 22.5. And then there is going to be a collected assignment after this. I think it was 23. It was a crossword puzzle. So go ahead and check that out as well afterwards. Good luck.